All right, good afternoon. It's always a little hard to be the first after lunch as people are settling in, but I hope that you had a good lunch. Oops, whoops. How's that? All right. So on behalf of the whole DART team, I'm going to give you a mission overview and our project status, and I'll be teeing up numerous other presentations that are going to come throughout the rest of the afternoon on specifics of engineering and technology and our SmartNav system, as well as our companion mission, HERA. You've seen this chart numerous times, and you know that DART falls in the mitigation category. And we fit quite nicely in the kinetic impact regime as a mitigation type of defense, and it largely went to the way that we picked our target so that we would have a very realistic target in the area where statistically there are most of our PHAs. So a little bit about our objectives, our threshold requirements. Of course, we are demonstrating the kinetic impactor technique. It was very important to us to pick a representative threat asteroid, our target, which I'll talk a little bit more about. Our primary purpose after we actually hit the target relative to where we hit the target will be to change the orbital period of the binary system, the small Diddy moon. This experiment, the whole basis of our results, will feed into our modeling and our prediction capabilities of the future that decision makers will indeed be making. And we had to come up with a very affordable way in order to do the experiment. You're probably familiar with one formerly called Don Quixote, which was more than $1 billion. And of course, that was not affordable for the community, so we worked very hard. And the binary system allows us to make our measurements using a very extensive ground-based campaign. And that is what we'll be leveraging post-impact. There's been some changes since you last have seen this. You're going to hear about a new trajectory that we have, a new ballistic trajectory, as well as we now have our launch vehicle. We'll be riding on a Falcon 9. That was recently announced, and we're all very excited about that. So our launch has moved by about 5 weeks, opening up on July 22nd, 2021. We also have a contribution that you'll hear about, a CubeSat from the Italian Space Agency that we're very pleased to be riding on board. I'll talk a little bit more about that. This, of course, is our target, our Didymos system that Mother Nature has been so kind to provide for us to set up this controlled experiment. You can see up in the far right that this shape model, we have a lot of data on Didymos. It's very well characterized, and we also have we continue to have an extensive pre-mission observation campaign where every time we have an opportunity to gather more data, we in fact are taking advantage of that. When we are also from APL, and where part of the idea came from, we're leveraging off of our DoD capabilities for this mission, and you will hear more about in Elena's upcoming presentation about SmartNav. And we indeed are very reliant and have a very robust post-impact campaign for our optical and radar observation program, where we'll be up to about a period of 3 months observing during the post-impact assessment about the change in the orbital period. We believe that we'll see that change between about 8 and 10 minutes, which far exceeds our actual requirement. Okay, DART is all about the terminal guidance for this intercept program. And in terms of planetary missions, it's a very short flight time. We're only, with the new trajectory, about 14 months in duration, where many of us are accustomed to 10 years to get to our ultimate target. So it's a very fast turnaround. So we start off with our cruise phase. We may do a flyby of another binary object. That will be a decision process that we'll go through during the commissioning phase. It's not till about 30 days where our single payload, our Draco visible instrument, will actually pick up and do a course acquisition of the system. It'll look like it's a single object. About 2 to 3 days before impact, we'll release the CubeSat, which is a flyby independent experiment in and of itself with its own comm direct to the Earth to get the data that they will collect. I'll talk a little bit more about that. When we get within several hours of the target, we'll be able to then discern that we have multiple objects. About an hour and a half in, we'll lock on to the Didymon and go into an autonomous targeting, and will impact the object over 6 kilometers per second. And then we'll go into our up to 3 months post-observation campaign, which is, of course, very important. And it's not to about 17 seconds before that we'll actually meet our requirement of 50 centimeters per pixel in terms of the resolution from our visible imager. So where are we? We're very busy and very excited about moving flight hardware through the system. Actually, in the June timeframe, we'll have propulsion tanks that'll be delivered. We have structure coming in June, and we'll be starting our propulsion INT. So we have a lot going on. You can see some of the team here off to the right with some of the hardware that's already well in progress. You see the illustration of the satellite up in the upper right. Elena will go into more detail. You can see these extensive rows of arrays. We have a lot of technologies on DART. We were confirmed last August, and coming up at the end of June will be our milestone, our critical design review. Some additional changes since we last met. Originally, we were a Class D mission. But the agency deemed at the last milestone review that we would become a Class C mission. The only real impact at the time that we had was the change from a commercial rideshare to a direct vehicle. Hard to complain about getting your own launch vehicle. So we're quite excited about that. And of course, we do know that it is a Falcon 9 and that we will be flying out of Vandenberg. Then we also have the CubeSat contribution from Ozzy, and we're also carrying another technology out of SMD's Pesto office, a transformational array that will be integrated into our ROSA arrays. And we're constantly taking Didymos observations. I have some data I'll show you of one that was just taken in Chile. And the next C, which is our companion project, of which we are getting our thruster and our power propulsion unit, are also started their flight production. That is GFE to DART. And this time next year, we will be deep into system integration tests. I wanted this international conference and planetary defense is all about international collaboration. And I think DART is a good model for that. You've heard about NASA's the preparedness plan that was published last June that they are following. We, of course, the primary goal, number 3 for the development of deflection and disruptive missions is where DART fits in, but DART also fits in quite well with goal number 4, increasing and encouraging international collaboration. We have that not only with the CubeSat, but we also have that with our Hera companion mission, which you're going to hear more about. And you hear this banner of IAA. And IATA stands, it's the brand, if you will, for the international collaboration, to bring in as much of the community as we possibly can, bring all that expertise to bear to the DART and the Hera mission combined. So I want to give a shout out to our investigation team. I feel like we have this amazing team pulled from all over the country. These are our leaders. This is our structure with our working group. You've heard many of that work over the last couple of days, and you'll hear even more throughout the conference. But I also want to recognize that we have international participation across the whole investigation team, across all of the working groups. And I won't read all this, it's in the package, and an extensive observing campaign. You can see some of the data just from Chile that we've gathered. And of course, we have everything that we need to do that campaign. A little bit about the Italian CubeSat, a 6U, and its capabilities. It's a replica of what's being built and flown on Argo Moon on EM1 on the first flight. And then the Hera mission, which is extremely important to us. The measurement, we talked about mass today. It's a critical measurement if it can be had. And the Hera mission, of course, would really definitize and quantify that mass measurement. And we look forward optimistically that they'll be chosen at the ministerials in 2019. With Hera, we would have taken this experiment to its fullest potential of what could be realized in terms of its results. And there is no overlap in measurements between the CubeSat and the Hera. That's always a source of confusion. Each bring their own very special contribution to the table. And I will wrap it up to say that by the next time that we have the PDC, we'll just be a few months before launch of DART. Thank you.